Assalamualaikum and hello everyone. In this video, we will be discussing about number 7 from the physics challenge questions. Okay, so 7a. A climber uses a nylon rope that has a length of 50 meter and 1 cm in diameter. The rope elongates 1.6 meter to support the climber of mass 90 kg. Determine the Young's modulus of nylon rope. Okay, based on the question, we know that this topic is from topic physics of matter, the first two subtopics, which is stress and strain, and then Young's modulus. Okay, so before we answer this question, I would like to bring your attention to the list of selected formula. So for the first two subtopics of chapter 8, the formula will start from the number 53 and then until 57. Okay, so 53 is the formula for stress, 54 strain, 55 is the Young's modulus, 56 is the strain energy, and 57 is strain energy per volume. Then the first thing to do is to extract all the informations from the questions. Okay, so these are the information, and then understand what the question wants. The question is asking for the Young's modulus. Okay, so just now we have looked at the formula for Young's modulus is equals to stress over strain. Okay, so now what you need to do is to find the value of the stress. So stress is equals to force over area. And in this question, the force is exerted by the mass of the climber. Okay, so for the force, we can say that is the weight of the climber. Mg over the area. And the area is actually about the cross-sectional area of the rope. Okay, so we can use the diameter given to find the area, which is pi d square over 4, or you can also use in terms of radius, pi r square. So now we just need to substitute the value for all the parameters. Then we will get the value for the stress is 1124143.94 and the unit is Pascal. Okay. Next, the strain. Strain is equals to the elongation over with the initial length. Okay, so given in the question 1.6 divided by 50, then we will get 0.032. And then remember for strain, there is no unit because for delta L is meter, length is also meter, so we can cancel out. For the unit, there's no unit for strain. Okay, so the last part is just to substitute the stress and the strain. So the value for the Young's modulus of the nylon rope is 3.51 times 10 to the power 8. Okay, so the unit will follow the unit of the stress because for the strain we have no unit. Okay, so the unit now is Pascal. Okay, move on to question 7c. A steel container of volume 0.189 meter cube. Okay, so we have a container and the capacity is 0.189 meter cube. Filled completely with carbon tetrachloride when the temperature is 10 degrees Celsius. So at 10 degrees Celsius, the container is completely filled, penuh. So this also means that the initial volume of the carbon tetrachloride is equals to the volume of the container. Okay, so they are having the same initial volume. Given the coefficients of volume, so the gamma for the carbon tetrachloride is 5.81 10 to the power negative 4. And then for the steel is 35 times 10 to the power negative 6. Okay, so if we compare the value of the gamma for the carbon tetrachloride, okay, so the gamma for carbon tetrachloride compared to the container is bigger. Okay, so this means that when heat is subjected to the container together with the carbon can expand more. It's easy for the carbon to expand. Okay, so that's why that will cause overflow. So in this question, you have to find how much of carbon tetrachloride actually overflowed when the temperature rises to 30 degrees Celsius. Okay, so let's go to the list of formula to see which formula we can use. Okay, so if you look at here, from number 65 is the rate of heat transfer. Number 66 is the change in the length. 67, the change in the area. 68 is the change in the volume. Okay, and then to calculate the overflow, we can use this formula because we have the gamma. We have the coefficient of volume expansion. Okay, so to calculate the overflow of the carbon tetrachloride, we have to take how much the carbon tetrachloride has actually expanded minus with how much the container has expanded. Okay, so and then we just substitute. We just use the formula just now. Delta V equals to gamma V not delta T. The container and also the carbon tetrachloride are having the same volume. Okay, but then they have different gamma. So when we minus, we will get the overflow volume. Okay, so that's all for number 7. Thank you.